Okay, this is number 4, take 2, because I botched up take 1. Okay, so here we go. Let's go ahead and draw this circuit, my resistor, my ammeter. Okay, and I'm not going to draw quite as many circles as there are in this whole entire thing, okay, because it's just too many. I can't keep track of it. Okay, but let's kind of draw it like this. Okay, so here's my my schematic. All right, you should have already done this. You shouldn't be doing this with me. You should be just checking yours. So I'm going to go through it pretty quickly, okay? All right, the battery provides a voltage difference of 12 volts. Resistor 1 is 6 ohms, and the total current is 5 amps. Okay, so we'll call this one R1, this one R2. All right, and then let's go ahead and fill in our voltage circles, okay? So remember, at the negative side of the battery, you're going to follow that 0 all the way around. Okay, so look, all of these are 0, right? Because I have not gotten any resistors in that path at all, okay? On the top side of the battery is going to be 12, so everything else is going to be 12, okay? Right, so you can denote the voltages anywhere. I draw them into the schematic. Miss Medrano does not. She draws them on the original picture. It doesn't matter. Any way really is fine at this point. It's cool. All right, just make sure that they're somewhere. Okay, all right, the ammeters, now the total current is 5 amps, okay? So that means on this path where the battery is going to be the total current, all right? So this just looks a little different, but look, this is still a parallel circuit because here there's going to be a split. Anytime, see how there's a junction? Anytime there's a junction and there's a split, there's going to be something parallel about the circuit, okay? Right? So if I look up here from 12 to 0, right, each of these resistors is taking that 12 volt drop. Okay? All right, so let's see what else we've got. So if remember, V equals I times R. All right, so 12 equals 5 times R. Okay, so R is going to equal the voltage over the current. Okay, yes, it's going to be a decimal. It's okay. Don't have a panic attack. Decimals are numbers too. 2.4 ohms is going to be the total resistance, okay? On the second line, 12 equals something times 6, okay? So that something's going to be 2 amps, all right? So up here in this top path, I'm going to see 2 amps coming through the top path, okay? So in a parallel circuit, you know that the current splits. So if there was 5 amps total coming in, 2 amps goes on the top path, then you know 3 amps has to go on the bottom path, right? Because remember, the currents are going to add to the total in parallel. Okay, and then 12 equals 3 times, this is going to have to be 4. Okay, so remember, this resistance value should be lower than your other ones, right? Because it's going to be always making the resistance less when you add more paths. Okay, all right, so let's go ahead and do this. A and B, C and D, C prime, D prime. And if you want to put like E, F out here, you can do that, or you don't have to. It doesn't really matter. Okay, so I'm just going to not do that. All right, I'm going to go to 12. So I'll go 3, 6, 9, 12. Oops. Okay, all right, so from A to B, I'm going to see a 12 volt rise. From B to C, I'm going to see a flat because there's nothing happening here, okay? And then I'm going to see my drop. So there's going to be an entire drop, okay? But then remember, there's also another path. So I'm going to see another path, either in another color or another something, shape or whatever, okay? And then it's just going to go back to A. All right, so I should see 2 paths again with a 12 volt drop. All right. So there is the total